Tornadoes, nature's fiercest engines. Tornadoes are among the most violent weather events on Earth. They are rotating columns of air stretching from the base of a thunderstorm to the ground, capable of destroying entire neighborhoods in minutes. What makes them so astonishing is not just the chaos they cause, but the sheer concentration of energy in such a narrow space. To unveil tornado power, we must look at how they form, how their strength is measured, and how their energy compares to other natural forces. Only then can we appreciate the true scale of these atmospheric engines. The birth of a tornado. Tornadoes are born inside supercell thunderstorms. These storms feature a rotating updraft known as a mesocyclone. When wind shear, changes in wind speed and direction with height, aligns with warm, moist surface air and cold, dry air aloft, rotation begins. Air converges, rises, and spins faster, much like a skater pulling in their arms. Under the right conditions, this rotation stretches downward and forms a tornado. The fascinating part is how much raw force is compressed into this process. A storm spanning dozens of miles funnels its energy into a column often less than a mile wide, concentrating wind speeds greater than almost any other phenomenon on Earth's surface. Measuring tornado power. The EF scale. Meteorologists use the enhanced Fujita EF scale to measure tornado strength. Instead of direct wind readings, which are nearly impossible to capture inside the vortex, scientists analyze the damage left behind. EF0, winds 65 to 85 miles per hour. Minor damage, branches snapped, roofs scuffed. EF1, 86 to 110 miles per hour. Roofs stripped, cars pushed off roads, power poles down. EF2, 111 to 135 miles per hour. Houses lose roofs, trees uprooted, vehicles lifted. EF3, 136 to 165 miles per hour. Entire walls torn from homes, trains overturned, heavy cars thrown. EF4, 166 to 200 miles per hour. Strong houses leveled, cars hurled hundreds of yards. EF5, over 200 miles per hour. Complete destruction. Homes swept off foundations, steel structures bent, trees debarked. An EF5 tornado is the pinnacle of atmospheric violence, with winds so strong they can obliterate entire communities. Comparing tornado power to other forces. To grasp tornado strength, it helps to compare it with other natural and human-made forces. A Category 5 hurricane has similar wind speeds, but those winds are spread across hundreds of miles. A tornado compresses that same force into a path often less than a mile wide. A jet engine produces hurricane-force winds inside its turbines. A tornado unleashes comparable speeds across neighborhoods, flinging debris as missiles. Scientists estimate that a large tornado releases 10 trillion joules of energy, comparable to several nuclear bombs, but concentrated over minutes and miles instead of milliseconds. Tornadoes are localized yet devastating, with power that rivals some of humanity's most destructive weapons. Wind speed and pressure. The main destructive element of a tornado is its wind. Radar measurements have captured winds exceeding 300 miles per hour in violent tornadoes. At such speeds, cars become airborne. Homes disintegrate in seconds. Concrete and steel structures sustain heavy damage. In addition to wind, tornadoes cause sudden pressure drops. Inside a tornado, atmospheric pressure can fall more than 100 millibars compared to the surrounding environment. This rapid shift can shatter windows and contribute to structural failure. Tornado size. From ropes to wedges, tornadoes vary greatly in size. Some are narrow ropes, twisting only a few dozen yards across. Others are colossal wedges, spanning more than a mile. The largest ever recorded was the El Reno, Oklahoma tornado of 2013, which reached 2.6 miles wide, wider than Manhattan. Within that vast vortex, winds approached 295 miles per hour. The true power of tornadoes is not just in their speed, but in the sheer scale of their rotating mass of air. Tornado longevity and path. Most tornadoes last minutes and travel only a few miles. But the strongest can endure for hours and carve paths over 100 miles. The tri-state tornado of 1925 remains the deadliest in U.S. history. It lasted more than 3 hours, traveled 219 miles across Missouri, Illinois, and Indiana, and killed nearly 700 people. In 2021, the quad-state tornado ripped across Kentucky and neighboring states for over 165 miles, leaving catastrophic destruction. These events highlight how sustained tornado power can rival that of much larger disasters. Tornado destruction, the role of debris. Tornado winds are deadly, but their ability to turn ordinary objects into weapons magnifies the danger. Wooden beams become spears. Vehicles weighing tons are hurled like toys. Straw has been found embedded into tree trunks, showing just how fast debris can travel. In powerful tornadoes, it's not only the structure of homes that is torn apart, but also the environment itself. Entire forests can be stripped bare in seconds. Psychological power. The human impact beyond physics, tornadoes carry a unique psychological weight. Survivors describe the roar as like a freight train or jet engine, overwhelming all other sound. The sight of neighborhoods reduced to foundations in minutes leaves a lasting imprint. Unlike hurricanes, which give days of warning, tornadoes strike with little notice. The suddenness of destruction amplifies the perception of their power, leaving communities shaken long after the skies clear. Scientific efforts to quantify tornado power. Because tornadoes are so violent, measuring their energy is difficult. Instruments rarely survive a direct hit. Researchers instead rely on Doppler radar on wheels, tracking wind speeds from a safe distance. Aerial surveys, mapping the width and length of damage paths. Computer simulations, modeling airflows inside the vortex. Projects like Vortex, verification of the origins of rotation in tornadoes experiment, have advanced understanding, but much remains unknown. Exactly why some storms produce violent tornadoes while others do not is still one of meteorology's greatest mysteries. Tornadoes in comparison to global phenomena. Tornadoes may not be the most energy-intensive natural disaster. That title goes to hurricanes, earthquakes, or volcanoes, but they are unrivaled in terms of intensity over space and time. In minutes, they can transform landscapes more dramatically than years of erosion. They are Earth's most violent atmospheric expression, proof that power is not just about scale, but concentration, preparedness, and respect for tornado power. Unveiling the scale of tornado power is not just about science, it's about survival. Early warning systems, storm shelters, and public awareness save lives. But no matter how much we prepare, tornadoes remind us of nature's dominance. Their ability to compress immense forces into such narrow paths ensures they will always rank among the most feared natural disasters. Respecting that power is as important as understanding it. The essence of tornado power. When we talk about tornadoes, we talk about rotating engines of destruction, winds surpassing 300 miles per hour, pressure drops that can collapse homes, paths stretching across states, destruction that defies comprehension. The true power of tornadoes lies in their ability to take the ordinary, a house, a car, a forest, and reduce it to rubble in moments. They are reminders that the atmosphere itself can wield forces as mighty as any geological event. Tornado power in a changing climate. The last piece in unveiling tornado power is how it may shift under a changing climate. While tornadoes are localized and difficult to track long-term, scientists are uncovering important signals. Instead of simply increasing in number, tornadoes may be occurring in more concentrated outbreaks, where a single day produces dozens of twisters. There's also evidence of a geographic shift, with activity migrating eastward into the U.S. Southeast. This matters because the region is more densely populated, forested, and prone to nighttime tornadoes, factors that make storms deadlier even if their physical intensity is unchanged. Warmer, moister air from the Gulf of Mexico may provide more fuel for violent supercells, potentially amplifying tornado power in ways communities must prepare for. These must